Good morning. If you guys don't know, it is a great day to be a trailblazer. I am representing the trailblazer family.
That was a bit too much.
That was a bit too much. Sorry if that was over the top. All right, let's start with derivative rules. Product rule. What does product rule tell us?
Bring the power down.
Product rule. Derivative of the first times the second plus the first derivative of the second. Quotient rule.
Low-D
high minus high low, low. Chain rule.
Take the derivative of
The derivative of the mama. Leave her baby alone. Times the derivative. Okay, derivative of 1 over x.
Whoa.
negative 1 over x squared.
Derivative of 1 over x is negative 1 over x squared. Derivative of the square root of x.
1
1 over 2x.
1 over 2 square roots of x. Derivative of sine of x. Derivative of cosine of x. Negative sine of x. Derivative of e to the x. Derivative of e to the negative x. It's the negative of e to the negative x, or it's e to the negative x times negative 1. It's a chain rule, because you already know the derivative of e to the x is e to the x. The derivative of e to the negative x is an example of e to the stuff power. So it's e to the negative x times the derivative of the stuff, which is negative 1. Derivative of natural log of x.
1 over x.
1 over x. And the derivative of tangent of x.
Secant of x. 2 secant. No, secant squared.
Derivative of tangent of x
Secant squared
is secant squared of x. However, you don't know the derivative of the secant of x, the arcsine of x, the arccosine of x, the arctangent of x, or any of the hyperbolic functions. Heck, you don't even know what a hyperbolic function is. We are quickly going through the derivative rules, which is wonderful, which then gets me to shut up. Reminder number 1, that derivative foldable is happening next door today during lunch. I've got the colored paper. We'll make the foldable. It's going to be wonderful for the friends at North Central. We're going to be filming that so that they can make their own little foldable. But, you know, it's kind of tough for them. Other thing is there's going to be a take-home quiz tomorrow that is going to be due on Monday. Holly Mom, why was that the funniest thing you've heard all morning? Okay. David, I wanted to touch base with you later on, and Carmen, I just wanted to publicly say thank you for making the first of many posters to come. Alright, correction. The assignment that got turned in yesterday, not so good. Not so good. That's coming around. Oh, Carmen, you don't have to do a special delivery. You can just throw papers at teenagers. Alright, last night you guys were responsible for doing, was it round 2? Which starts with what problem number? 6? 5. 6. Okay, so that's being an overachiever. Alright, problem number 6, if all goes well, you have e to the x squared times 2x. E to the x squared times 2x, or 2x times e to the x squared, same thing, right? Just check, did you get it right? Number 7, natural log of stuff, so we're going to have 1 over stuff times the derivative of the stuff, which is e to the 3 plus x squared times 2x. Myra, why times 2x over here? Right, you've got another chain rule that's needed over here. You've got a mama and the baby, but the baby also has her own little baby. Alright, number 9, a to the x times e to the bx. What derivative rule do we need first?
Chain number 8.
For number 9. A to the, oh, we skipped number 8, didn't we? Alright, so derivative natural log of 1 plus all that stuff is going to be 1 over 1 plus e to the all that stuff, times the derivative of the denominator, times the derivative of that exponent there, times the derivative of 3 plus x squared. So you've got like a chain rule inside of a chain rule inside of a chain rule inside of a chain rule. If you're getting it wrong, just fix it. Give yourself some feedback. Number 9, a to the x times e to the bx. Product rule. Right, as soon as you see that you're doing a multiplication problem, it has to be a product rule. Take the derivative of the first part, which is a, leave the second part alone. Plus the first part times the derivative of e to the bx is going to be e to the bx times b. Number 10, another product rule question. Derivative of the first, leave the second alone. Plus the first times the derivative of the second is e to the cosine of x times negative sine of x. Number 11, negative sine of e to the x times e to the x plus e to the cosine of x times negative sine of x. How are folks doing with this? Doing mostly okay? Good. All right, number 12. It is so helpful if you just know certain forms, like square root of stuff. I automatically went to, oh, derivative of square root of stuff is 1 over 2 square roots of stuff. I don't even have to think about that part. And now I'm going to have to do quotient rule. And that d dx notation is going to save your life. You've already done part of the derivative. I don't want you to worry about doing quotient rule at the same time. So just say d dx of stuff, and then a little low d high minus high d low, low low. Let's just check 1 or 2 more of these together. How far did you guys have to go?
17.
17. All right. Number 13. I want you guys to put a star next to this one. This one gets everybody all the time. Sine squared of x or cosine squared of x. Part of it is I think people get confused and they see the sine squared of x and they're like, oh, does sine squared of x, is that the same as sine of x squared? Or is it sine of x, the whole thing squared?
The whole thing squared.
It means sine of x, the whole thing squared, right? And so if you know, okay, sine squared of x doesn't mean this, sine squared of x means this guy here, when you're going to take the derivative, which derivative rule?
Chain.
I can handle product. I can handle product rule. Because you might see it as sine of x times sine of x. Where are my chain rule people? Andrew sees it as chain rule. I've got stuff squared. So the derivative would be 2 times the sine of stuff to the first power times the derivative of the inside, which is cosine of x. Either way you want to do it is fine. Chain rule, go for chain rule. You see it as product rule, see it as product rule. How many of you guys would do this as a product rule problem? I'm just curious. Okay. But do we see the chain rule? Mm-hmm. Good. All right. Number 14, sine of stuff. Derivative of sine of stuff, cosine of same stuff times derivative of the inside, which is cosine theta minus sine theta. Number 15, sine of theta times sine theta plus cosine theta. Now you need product rule. 16, natural log of stuff. Derivative is going to be 1 over the stuff times derivative of the stuff, which is 1 over x. Aaron, can I erase this? Yeah, sorry. I almost used the sweatshirt. That would have been sacrilege. And number 17, last one, quotient rule. Derivative, low, d high, so x to the k, it's going to be k times x to the k minus 1, minus high, d low, low, low.
So on the test, it's going to be all about showing you get the notation.
Say that one more time.
Like we're not going to have to solve anything.
You're not going to have to simplify. However, if it is the multiple choice part of the test, I need you to know that things like 1 over the natural log of x times 1 over x would also be legal to represent as 1 over x times natural log of x. And there we go. Perfect. All right, friends, let's move on. The goal for today is I want to push. So if you can just leave the homework in the middle of the table, I want to push the thinking as much as we possibly can. These first 3 problems, I think you guys should be pretty much set to go. As it is, I want to give you the first couple minutes. Show me what you can do with 1, 2, and 3, and then I'm just going to start picking some papers. We'll put them under the document camera. Sadly, I have no new derivative rules for anybody today. Today's going to be really a practice day. We only have 30 some odd minutes. So show me what you can do. I'll pick up some homework. Corrections that they're going to do on any of the assignments for this 6 weeks. This is the file over here. have homework? We're missing. Where do we go? Yeah.
How's it gonna be controlled here?
Yeah.
You apply that to this? Treat this as a product of this?
It absolutely is a product of good x squared times f of 1 over x. So I will take this tomorrow, but not after tomorrow. Okay. Tomorrow's not a full credit. Alright, first one, if I'm going to read this correctly, I've got x squared times f of 1 over x, which is hopefully screaming to everybody in the room, product rule. Okay. So, product rule says take the derivative of the first, leave the next guy alone, plus leave the first one alone, times the derivative of f of 1 over x. And for right now, I'm just going to write that this way, because quite honestly, I'm not ready. I'm not ready to do this derivative in the midst of everything else. So I would say if you got here, you just picked up the first point. Okay, next point comes in by finishing off the calculus. I need to take the derivative of f of 1 over x, derivative rule that I need here. There was an audible clue there, f of 1 over x. As soon as you say the word of, this always means chain rule. So the derivative of f of 1 over x should be derivative of the mama, leave the baby alone, times the derivative of the baby, which is derivative of 1 over x. I just want you guys to have this one memorized. Derivative of 1 over x is negative 1 over x squared. So a good answer is 2x times f of 1 over x plus x squared times all that. That's a good answer. How many of you guys would have had that as your answer? One person? Two people? Three? Okay, for the folks that didn't get this right, where are we going wrong?
Oh, I got that.
I just left it in my
I got the purple.
Oh, okay. You can't leave it here because you're not done with the calculus, right? There's still like derivative work to do. Leaving it in the purple is fine. This would get you the second point. However, if we're talking about multiple choice, there is a way that I'm going to hide it from you. I'm always going to push the tricky algebra. How am I going to hide this answer from you on the multiple choice? You're going to have it, you'll have done it right, and then there's some algebra trickery.
Oh.
So that's what he said.
When you multiply the x squared times the negative 1 over x squared, it would become
These guys over here, right, x squared times negative 1 over x squared, you guys know what that is. Is it just negative 1? So you're going to have negative f prime of 1 over x. 2x times f of 1 over x minus f prime of 1 over x. This is no better than the work that we had over here. On free response, this is a safe stop. But on multiple choice, this is the way that I'm going to choose to write it, and you just need to know it. Okay. All right, see what you can do in the second one. Ooh, some people like pain. It is very loud next door. I'm not sure why they're watching a movie in that class. Oof. All these people that like pain. So here's what I'm seeing so far. G of x is the natural log of the square root of all the stuff. Clearly a chain rule. Oh my God, a chain rule. An ugly chain rule. So I'm seeing G prime, derivative natural log of stuff is 1 over stuff. A, and what is, I can't see that. Sine.
B times f of x.
B times f of x. Okay, not the final answer. Right? Why not? Now I've got to take the derivative of all the stuff. Derivative, square root, a over sine b times f of x. Whew. Still not done. I'm going to take the derivative of the square root of stuff, but I know the derivative of the square root of stuff is 1 over 2 square roots of the stuff. Like it. Love it. Not done, because now I need to take the derivative of the stuff. A over the sine of b times f of x. Hopefully everybody's still okay? Don't forget, you still get this 1 over the square root out in front. All right, so here's how many of you guys are honestly had this? Okay, still not done. Still not done because you got to finish off the calculus. You're still having to take a derivative, which means what you need here is quotient rule. A over sine of b f of x. Quotient rule. Think quotient rule. Quotient rule here tells me low, so sine of b times f of x. Low d high, derivative of a? 0. Is 0 because we've got a constant. Minus a times derivative of sine b times f of x. Derivative of sine is cosine. So we've got b times f of x, not done because I need to take the derivative of the inside here. B is a constant. B times f of x is going to be b times f prime of x all over, oh my God, sine of b times f of x, the whole thing squared. That's your answer. What a pain. Let me show you another way. So option 2. We've had some conversations about algebra, and algebra being legal. We've got the natural log of a over the sine of b times f of x. Does anybody have any legal algebra that you know of that you could use here that might simplify your work? That looks like a collective no. Log properties. There are some log properties that you are responsible for knowing that would make your life so much better here. For example, you guys know something called the p in front of the log property?
No.
You drop that p. P times the natural log of m. That's the thing where, like, you might say, oh, I'm working with the natural log of x to the 4th. That's the same as 4 times natural log of x. That's not calculus stuff.
Oh.
Steven, can you turn the camera? All right, we're good. So this is like the p in front of the log property. It allows you to bring the power down in front. Why would that be helpful here? Right, this square root, you guys know, to say natural log of the square root means natural log of all that to the half power. Now what happens, p in front of that log, I've got 1/2 the natural log of a over the sine of b times f of x. Already a little bit easier because I've taken out one of my chain rules. There's more. I've got the natural log of a quotient. There was a log property there. If you're taking the log of a quotient, you've got a log of something divided by something else.
Natural log.
Would it be a divided minus b?
It's the natural log of a minus the natural log of b.
Yeah.
So rather than saying natural log of this guy here, I've got 1/2 of the natural log of a minus the natural log of the sine of b times f of x. That half has to get distributed all the way through. So we've got 1/2 natural log of a minus 1/2 the natural log of the sine of b times f of x. Now let's finally take a derivative. Derivative of 1/2 natural log of a. We know something about a. It's a constant. So if a is a constant, the natural log of a constant must be 0. And half of 0? 0. Minus 1/2. I need to take the derivative of the natural log of the sine of b times f of x. Derivative of natural log of stuff. 1 over the stuff. The derivative of the stuff, cosine of b times f of x. Derivative of this stuff in here is going to be b times f prime of x. Although the log properties may not have been something that you snapped to right away, does everyone at least see that if you had the log properties accessible and use them well, derivative life just becomes a whole lot better? A whole lot better. So, in addition to knowing that the natural log of something to a power is that p in front of the log property, and knowing the natural log of a quotient, the other log property that's really helpful to have is if you have the natural log of a product. If the natural log of a quotient means the difference of two logs, then the natural log of a product should be the sum, the addition of two logs. Well said, natural log of A plus the natural log of B. Those are the ones that I'd encourage you guys to get locked down. Everybody okay? All right. I'm not too worried right now about you guys doing number 3. Here's what I would encourage you to do. Yes. On page 24 on the back, there's a whole bunch of just generic problems here where we're mixing in derivative rules with a function f of x. Let's see what you guys can do. We've got about 9 minutes before class is over. Ideally, you'll be able to get through 1 through 6. These should be relatively quick by comparison. Can I get you to read the first one? Like, how would you read that using like good, proper math vocabulary?
G of x equals cos f of x.
Oh, you skipped over the most important word here.
Of.
Cosine of. The reason I want to emphasize that word of, like, that's the clue. Right, if I'm going to take the derivative of cosine of f of x, and the rule that I need, chain rule. Okay, Andrew, finish off.
Plus f of cos.
F of cosine of x, so another chain rule showing up. Okay, g prime. The derivative of cosine of f of x should be negative sine of f of x times f of x, plus derivative of f of cosine of x is f prime of cosine of x times derivative of cosine of x, negative sine of x. How many guys honestly have that as your answer on the first one? Okay, we're looking like we're in a good place. Friends over here, are we okay? Okay, good luck with number 2. Yeah.
Yes, and you need to remember you're doing an actual one of stuff. So it's 1 over stuff times the derivative of the stuff.
Oh, yeah.
Man, there are some people in this room that like pain. So much pain.
No pain, no gain.
You write it 1 over.
You're right, no pain, no gain, but sometimes no brain. Natural log of the square root of x times sine of f of x. I just walked around. I did not see anybody make a smart opening move here. Aaron, what's the smart opening move?
Put it all 1 over the whole thing.
Okay, that means like you're like already like you're taking the derivative. There's a really smart opening move that's going to save you so much time. David, smart opening move?
You can put natural log of square root of x plus natural log of sine.
Natural log of the square root of x plus the natural log of sine of f of x is such a smart opening move, David. Why?
Because it gets easier.
That's going to make things a whole lot easier. Like Celeste had a, she was like 1 over the stuff, then it was taking the derivative of the stuff, but to take the derivative of the stuff you need product rule. You skip the product rule if you use your log properties. Even better, maybe I'd rewrite natural log of the square root of x as natural log of x to the half, and then bring that half down in front. So the derivative in an ideal world, h prime of x, what do we get here? Derivative of half natural log of x is going to be a half times 1 over x. Plus, when I get to the derivative of natural log of sine of f of x, I'm going to have 1 over sine of f of x times cosine of f of x times f prime of x. If you use the log properties on the front end, it's going to make the derivative life a whole lot easier. For those of you that didn't do it that way, your answer would be 1 over square root of x times sine of f of x, parentheses, derivative of the first guy, 1 over 2 square roots of x, times sine of f of x, plus now you leave the square root of x alone, times the derivative of sine of f of x, which is cosine f of x, times f prime. Okay. And because you guys are in Calculus BC, I want to push a little bit more. There is a way that you could simplify this final answer using your trig knowledge. 1 over sine could also be written as...
No, it's not cotangent, it's
1 over sine is cosecant. But I did hear Carmen say cotangent as well for a really good reason. Cosine over sine is cotangent. So there you're not using calculus, you're using your trig to write this whole thing as cotangent of f of x times f prime of x. So we'd have 1 over 2x plus this. This is a great answer. This is a great answer. Don't sweat it. All right. How about number 4? F of square root of x. Take 1 minute. Show me what you can do. Number 4. F of square root of x. I keep making a big deal about that word up, but really that's a clue. That's a really good audible clue for you. If all goes well, derivative is going to be, what do we got here? Derivative of f of square root of x. Chain rule. F prime, leave her babies alone, times the derivative of the baby, which is f prime of the square root of x, times the square root of x, which is 1 over 2 square roots of x. Everybody good with that one? All right, last push, number 6. I'm being a little bit mean with number 6. Yeah, number 6.
No, it's not.
And before you're like, wait, what is that derivative? You don't know it. All right, at no point have we talked about the derivative of secant of anything. You need something clever, some clever way around this. What you got?
You can write it as 1 over cos of f of x squared.
Right, I can say that this is 1 over the cosine of f of x squared, and hopefully at this point, the cat's out of the bag, we get this under control. Quotient rule. But it's seeing that this secant is the same as 1 over the cosine. That's going to be the way around. You're like, I don't have this derivative rule. Yes, but you have this one over here as a quotient rule. Okay? So, tonight's homework is the assignment for number 42, all the parts. I'm going to pick this one up tomorrow. Do a good job with this. And tomorrow we're going to do the next sticker challenge. And oh my goodness, I got to take this sweatshirt off. I think I've lost 8 pounds in the last period, which is a good thing.